Welcome to our physics classroom. Good day, everyone. I hope you are doing fine and you are now done with the learning activities that I assigned you last week. And for today, we're going to tackle about Newton's law of universal gravitation. Isaac Newton compared the acceleration of the moon to the acceleration of the objects on Earth, just like in this example. So we have here the moon moving in this direction, so to tell that it has acceleration, and also an object on the Earth, and he uses apple as the object or to illustrate the acceleration of the object on Earth. Based on this illustration, Isaac Newton believed that the gravitational forces were responsible for each. From that illustration, Newton was able to draw an important conclusion about the dependence of gravity upon the distance. So, you have to take note that the gravity also depends on the distance based on the illustration. Another one, this comparison also led him or Isaac Newton to conclude that forces of gravitational attraction between Earth and other objects is what? Inversely proportional to the distance. So the relationship between the gravitational force and distance is inversely proportional. That distance meaning that is the distance separating the Earth's centers from the object's centers. Also, from this illustration, um, Newton said that force that causes the apple to accelerate must be dependent upon the mass. So, kanina, we consider that force depends on the distance. In this case, uh, Isaac Newton also concluded that this force is also dependent upon the mass of the apple. And according to him, since the force acting to cause the apple's downward acceleration also causes the Earth upwards acceleration based on Newton's third law of motion that we've discussed last time. So, from that, he concluded that force must also depend upon the mass of the Earth. So, we need to consider the mass of the Earth and also the mass of the apple and also the distance separating them. So, that idea lead him to the conclusion or to the conceptualize about the Newton's law of universal gravitation. So, for you to understand it more, based on the illustration that we've shown a while ago, let's have a clear illustration that will show you the formula or the equation about this topic, which is Newton's law of universal gravitation. So let's say in this example, I have here a massive object, which is the Earth, and another object, which is the Moon. So, based on universal law of gravitation by Isaac Newton, every particle in the universe attracts every other particles. So, meaning, this Earth attracts the Moon and Moon attracts the Earth. So, to show that, let's put force here to show that this force is the force exerted by the Earth towards the Moon. And another one, we also have Fm as the force exerted by the Moon towards the Earth. According to Isaac Newton, every particle in the universe attracts every other particles with a force. So we have a force that is directly proportional to what? To the product of their masses. So according to Isaac Newton, the forces attracts or the forces that attracts these two objects is equal or directly proportional to the product of their masses. So we have to multiply the product of their masses, and this is directly proportional to the force. And another one, he also said that every particles in the universe attracts every other particles with the force that is directly proportional to the product of their masses and inversely proportional to what? To the square of the distance between them. Okay, so That is the value of the force based on the universal gravitational force. Let's say this F is the force of gravity. So that force of gravity is directly proportional to the product of their masses, but inversely proportional to the square of the distance between these two objects. Another one, to show the proportionality between this equation, we have to put the letter G. What is this letter G? Letter G stands as the universal gravitational constant. Okay, so what is the value of this G? So pag nag-solve tayo mamaya, the value of a G would be 6.673 times 10 raised to negative 11 Newton meter square per kg squared. So that is the value of our universal gravitational constant. So we will put it here to show the proportionality. So we have the constant here. So later, pag nag-solve tayo, gagamitin natin yan mamaya. Again, here is the universal gravitation equation. As you can see in this example, so the formula for universal gravitation is we have Fg as the force of gravity. So I use my pointers. Fg as the force of gravity equal to the universal gravitational constant, which is the G, multiplied to the mass of the object 1 and multiplied to the mass of the object 2 over the distance, square of the distance between these two objects. So here's the value of our G. So again, so here's the definition for each mnemonics. So we have Fg as the gravitational forces. So F grav, or we put that one. M1 and M2, the masses of the these two objects. And we have D, or we can use D, or we can use R as the distance between them. G as the universal gravitational constant. Now let us start understanding the proportionality about Newton's equation. So we'll begin with the effect of mass on the gravitational forces, or the F grav. So we will start to understand how the mass affect to the gravitational forces. So let's say you double the mass of one object. For example, I have here two objects here. And then I double the mass of this object. What will happen to the forces of attraction between them, or the gravitational forces between them? The gravitational forces between them will double. So, meaning the mass and force are directly proportional. As you increase or as you double the mass of this isang object lang yun nandito, so ito remains the same pa rin. If ito daw ay double the mass of this one, the force will double. As simple as that. Another one, if you double the mass of the two objects, let's say, dalawa naman sila na dinoble natin. Kanina isa lang, yung object na nandito lang. In this case naman, dalawa. We double the mass of this object, and also we double the mass of this object. What will happen to the force of attraction between them, or the gravitational force? The gravitational force will quadruple. Okay. So, kasi dalawa na silang dinoble mo, no? Unlike kanina, yung isang object lang, so double lang din. In this case, dalawa na yung mass natin. Sabi nga natin, the force is directly proportional to the product of their masses. As you can see, 2 times 2, that is equivalent to 4. So, the force will quadruple if dalawang object na yung nag-double yung mass. What if you triple the mass of one object? So, meron tayong object. I tripled the mass of this one and still the same pa rin to. What will happen to the force of attraction between them, or the gravitational force? So, the gravitational force will be equal to triple. No? Kasi yung isang object lang naman yan. So, as simple as that. That is the relationship between the mass of the object and the gravitational force. Now, let us proceed with the effect of the distance on the gravitational force. Sabi kanina sa problem, sa equation, distance is inversely proportional to the gravitational force. Let us see if that is true. Okay, if the separation of distance between the two objects is double. As you can see in this example, I have here 2D to show that the separation of distance between these two objects is doubled. What will happen to the forces of attraction between them or the gravitational force? So based on this illustration, the gravitational force, if you compute it, the value will be decreased by factor of 4 or that is 1/4, no? So it is doubled. So this one is decreased by factor of 4. Kasi sa formula natin nakalagay r squared. So squared natin tong 2. So that is 4. Kaya magdi-decrease siya by factor of 4. So that is equivalent to 1/4. So if you double the distance of the object, no? If you double the distance between the two objects, the force between them will decrease. No? Nag-increase siya ng factor of 2, ito naman magdi-decrease by factor of 4. Okay, so para mas maintindihan, tingnan yung formula. Makikita nyo dun sa formula nakalagay r squared. So dapat, sabi dito, nag-increase siya by 2. So dapat magdi-decrease siya by 2, i-square pa natin yung 2, kaya magiging 4. Okay, next. What if the separation between any two objects is half? Nahati siya or it is decreased by 2. So, nag-decrease by 2, medyo mas naging malapit sila sa isa't isa. So, ang force niyan dapat mag-i-increase kasi nga inversely proportional ang distance, square ng distance is inversely proportional to the force between them. What will happen to the force between them? Okay, so the force between them will be increased by factor of 4. As you can see, decrease by factor of 2. So, ito, mag-i-increase by factor of 2. Square mo pa yung 2, kaya magiging 4. Okay, inversely proportional kasi sila mga anak, huwag kayong malilito. So, dito, nag-decrease by factor of 2. Dito naman, mag-i-increase by factor of 4. Ma'am, bakit po ganun? Nag-decrease lang naman po ito ng 2. Bakit po dito hindi po 2 ang nakalagay? Kasi ang nakalagay sa formula natin ay r squared. So, mag-i-increase ito ng by factor of 2. Ito, magdi-decrease by factor of 4 kasi square mo pa yung 2. So, for you to understand it more, let us have another example. Let's say naman dito, ang ating separation of distance between these two objects is tripod. So, mas naging magkalayo sila. So, that is tripod. Of course, ito, dahil ito ay nag-increase, ang magiging force natin dyan, magdi-decrease. So, dito nakalagay tripod. So, dapat yung sa atin, yung force between this is decreased by factor of 3. Kaya lang, sabi dun sa formula, naka-square. So, i-square natin yung 3. And the square of 3 is what? 9. So, as you can see in this example, then the force of gravitational attraction is decreased by factor of 9. And, so, magiging 1/9 yan. So, para mas maintindihan pa natin yan, kung hindi pa rin naiintindihan tong sa equation natin, kasi ito increase, so dito decrease, kasi inversely, pag sinabing inversely, yung isang quantity mag-i-increase, yung isang quantity naman mag-decrease. So, i-show natin siya as equation. So, like this one, yung solution natin na to, i-show ko lang siya dito. Ito yung previous slide natin, di ba? Okay. Ayan. If the separation distance between any two objects is threefold, or meaning it is increased by 3, then the force of gravitational attraction is decreased by factor of, dun kanina sa illustration natin, by factor of 9. Paano nakuha yun, ma'am? So, solve na lang natin para hindi kayo mahirapan. So, let's have the given. So, we have factor of 3, and that is the value of our distance, no? And then, yung mass, wala naman binigay, so we will put 1. And mass 2, wala ding binigay. So, we will put 1. And the value of G will also be 1. Kasi ito lang ang given natin. So, the required for this problem, ang sabi dyan, what is the force of gravitational attraction? So, that is the F grab. Okay. So, equation kasi natin, same yung pinakita ko kanina, that is force of attraction or the force of gravity is equal to G multiplied by the product of this M1, M2, or multiplied M1 times M2 over R squared. And then sa solution natin, substitute lang natin to dito. So, this will be look like this. So, we have F grab is equal to 1, yung value ng G. 1, value ng mass, 1. Mass 2, 1. And 3. Ano yung 3? That is the distance. So, 3, square natin yan. So, the answer is 1 over 9. So, 1 times 1 is 1. Times 1 is 1 over 3 times 2, or 3 times 3 is 9. So, that is the solution. Pero kung iisipin mo, pwede mo naman nang hindi isolve. Pinakita lang din naman para mas maintindihan. Okay. So, let us prove the relationship using the equation. Okay, let's start with this problem. So, for this problem, we will solve this together. So, you just have to follow me to find the answer. Let's start. Okay. Suppose that two objects attract each other with a gravitational force of 16 units. If the distance between the two objects is doubled, what is the new force of attraction between the two objects? Okay, to solve this problem, we need to find the given. As you can see in the problem, the given is the value of the force or gravitational force, which is equivalent to 16 units. So you just have to write it down on the given part. So we have F initial, or the initial force, which is equivalent to 16 units. And it was also given in the problem that the distance between the two objects is doubled. So just write here in the given part of your solution. So R is equal to doubled, or that means 2. Okay. And then I put here M1 as 1 because we don't have the value of mass. And another one, another given is the mass of the object 2. I also put 1 kasi wala naman, just to show the proportionality. Okay. And another is the value of our G, 1. So, just like yung ginawa ko kanina sa solving. So, nilagyan ko lang siya ng 1. Since, ano naman to, ang hinahanap dito is the proportionality. To show the proportionality between force masses and the distance. So, for this, the required, it was already given in the problem. So, we need to find the new force of attraction between the two objects. So, let's have F new. Okay. So, you knew the equation, and that is equal to G is equal to M1 M2 over R squared. Now, we can proceed with the solution. For our solution, you just have to substitute this given to the equation. Okay, so that is F new is equal to the 1 value of our G, 1 value of our mass, 1 value of our mass 2, and 2. So, kanina, gaya lang din yun ng pag-solve na ginawa ni ma'am kanina sa proportionality. So, doing the math, the answer would be 1 times 1 times 1 equals 1, and 2 times 2 is equal to 4. So, the proportionality is this. So, the value of our new force will be 1/4. If the force from the very start is 16 units, so we need to calculate this one. This is not the final answer pa. Ang kinuha lang natin is yung value ng proportionality ng ating force if we doubled the distance. Ang value talaga ng force natin is 16. Solving this one, no? Ito lang yun. Sinolve natin. Nakuha natin yung proportionality and that is 1/4. Meaning, if I double the force, no, the force of gravitation between the two objects will be 1/4. Binigay ko na rin yan kanina. Kaya lang sinolve natin. So, hindi pa to final. Kailangan natin kunin yung 16 units. So, ang gagawin lang natin, we just have to multiply 16 to the value of proportionality that we solved, and that is 1/4. So, 16 times 1/4, so we have 16 times 1 is 16 over 4. So, the answer would be 4 units. So, as simple as that. No? Ang sinolve lang natin kanina is the value of proportionality between them. If dinoble daw natin ang force, what will happen? If we double the value of the distance between the two objects, what will happen to the value of our force? So, by calculating that, we get 1/4. So, ano ba yung 1/4 ng 16? That is 4 units. Okay, I hope you understand this one. Let us have another problem. Okay, 'di ba ito yung problem na binigay ko kanina? So, yung problem na binigay ko kanina na sinolve natin, without doing the solution, no, we can find the right answer for this problem by merely reflecting on the concept of universal gravitational law. It was stated there, the relationship between the force of gravitation, the mass of the object, and the separation of distance between them. So it was stated there that the force is directly proportional doon sa mass ng dalawang object pag minultiply. And at the same time, inversely proportional siya dun sa square ng distance or separation of distance between the two objects. So, based dun sa problem, basahin lang natin ulit. No? Sabi, suppose that the two objects attract each other with gravitational force of 16 units. If the distance between the two objects is double, what is the new force of attraction between the two objects? By merely looking the problem, if the distance is increased by factor of 2, you know that distance and force are inversely proportional to the square. So, magiging sagot dyan, the force will be decreased. So, nag-increase ang distance, ang force magdi-decrease kasi nga inversely proportional sila. Kaya lang, it will decrease by the factor of 2, by the factor of 4, sorry, hindi 2. Bakit po naging 4, ma'am? Kasi sa formula natin, di ba nakalagay doon that r squared. So, you have to square the r. So, that is 2 square, that is equivalent to 4. Kaya, kapag ang distance nag-increase by factor of 2, ang force natin will decrease by factor of 4. So, dun sa given natin, no, if that will decrease by factor of 4, that is equivalent to 1/4. Ano ba yung 1/4 ng 16? That is 4 units. So, as simple as that. So, kahit hindi ka mag-solve, by merely understanding the equation, you already get the right answer for this question. Now, let us proceed with the calculations. For you to understand more and apply the equation that we've discussed a while ago. For this part of the problem, I want you to bring out your pen, paper, calculator, or those things that you need to use in order to solve those problems that we will solve in this video presentation. Okay, since we will do solving, I will introduce the mnemonics that I want you to use to make your solution more easier to check and at the same time, more easier to understand. And that is GRESA. GRESA stands for G as given, R as required, E for equation, S for solution, A for the answer. So for this part of the video, you're going to use Newton's gravitation equation to solve problems. Okay, for problem number 1, you are going to solve this together with me. So, sabay tayong magsosolve. Okay, let's start. Determine the force of gravitational attraction between the Earth and the mass of the Earth is given, that is equivalent to 5.98 times 10 raised to 24 kg. As you can see in the problem, it was given in scientific notation. Kasi nga, masyadong malaki na yung value ng mass ng Earth. Kaya naka-scientific notation na siya. So, yun nga yung base sa dati nating lesson, no, to make the number shorten, a very large number in shorten, naka-scientific notation siya. So, raised to 24. And another given is the mass of the student, a physics student. No, napakabigat ng physics student natin. That is equivalent to 70 kilogram. Okay, if yung student natin, no, is in an airplane, and that airplane is 40,000 feet above the surface or the Earth's surface. So, nasa taas siya ng Earth's surface, nasa loob siya ng eroplano, no, ang taas nun is 40,000 feet. That 40,000 feet would tell us that the student distance from the Earth is equivalent to 6.39 times 10 raised to 6 meters. So, naka-scientific notation kasi masyado nang mataas yung value in meter nung layo ng student and yung surface ng Earth. Okay. So, this problem would require us to calculate the gravitational attraction. So, madali lang hindi tayo magde-derive ng formula kasi yun na yung hinahanap. So, let's find the given, the required, the equation, the solution, and the answer. For the given, it was already stated, yung mass ng Earth, that is 5.98 times 10 raised to 24 kilogram. Lagay na agad natin yan sa given. Okay. And another given is the mass of the physics student. That is equivalent to 70 kilograms. Okay, so we have 70 kilograms. So, we have the masses of the two objects na. And another one is the separation of distance. Gaano ba kalayo yung student above the Earth or surface of the Earth? That is 6.39 times 10 raised to 6 meters. So, that is the separation of distance between these two objects that is being compared. Another given is the value of the universal gravitational constant, and that is 6.673 times 10 raised to negative 11 Newton meter squared per kilogram squared. So, it was not stated in the problem, but since we are dealing with gravitational force, you have to include this constant, no? This is very important. So, wag kakalimutan yun. Kahit wala sa problem, you know that it is really need. Okay. And for this problem, ang sabi, we need to determine the force of gravitational attraction. So, lalagay na natin yun agad sa given. Okay, equation natin, flash lang natin, binigay ko na kanina. So, the force of gravitation can be calculated by G multiplied to the mass of the first object multiplied to the mass of the second object over or divide to the square of the distance or the r. So, minsan nakalagay dyan d, okay lang din yon. So, for this, since we're dealing with the earth, no, and mapapansin natin, we use this r, no, as to note the distance between the two objects. Okay. Now, hindi na natin kailangan mag-derive kasi iyan na yung hinahanap. So, we just have to substitute this given to the equation. So, solution, we have the force of gravitation is equal to 6.673 times 10 raised to negative 11 Newton meter squared per kilogram squared, the value of G, multiplied to the 5.98 times 10 raised to 24 kilogram mass of the earth, and multiplied to 70 kilograms mass of the student, divided by the r, which is 6.39 times 10 raised to 6 meter and then square. So, wag nyo kakalimutan na isulat yung square, lalo na pag nag-solve. Kasi, tama na yung ginawa mo, kaya lang nakalimutan mong square dito. So, you will come up with the wrong answer. Sayang naman yung effort. Okay. Doing the math, pag sinolve natin to, pwede natin tong ilagay lahat sa calculator. Or, pwede namang isolve nyo muna to, multiply lang natin tong tatlo na to, divide by this quantity. No? Or, pwedeng ilagay na lahat sa calculator. If we solve this problem, no, the value of our force would be 686 Newton. No? Bakit naging 686 Newton na lang? Makakancel na kasi natin yung meter, yung kilogram, no? And then, dito, yung m squared, kilogram squared. Makakancel na natin yan. So, makukuha na natin. Matitira na lang unit is the Newton. So, the answer would be 686 Newton. So, medyo malaki yung value ng ating force of gravitational force kasi mataas yung value ng ating mass, no? Ang mass ng Earth and mass ng ating physics student. And hindi naman din ganun kalayo yung Earth and yung students. So, yan yung force of gravitation between them. I hope you have the same answer with me. Here is the problem number 2. Let us read it first. Two spherical objects have equal masses and experience gravitational force of 25 Newton towards one another. Their centers are 36 centimeters apart. Determine each of their masses. Okay, before we proceed with the solution, let us take note that in finding the masses of this object, we have to consider the condition in the problem, which says that the object or these spherical objects have equal masses. So instead of finding two masses, you just need to find one mass, and that is equivalent to the other one because they have equal masses. Okay, for this problem, you will be the one to solve this time. Okay, all you have to do is just to pause the video for a while and just 5 minutes or 3 minutes. It depends on how long will take you to solve this problem. No? Okay, so after that, you may play the video for checking. So let's start. You may now proceed with your solution and pause this video. Okay, so let us assume that you already have your answer with you after posting the video. Let us check if your answer is correct. Just follow my solution and check your problem or your solving. Okay, let's start. So in this problem, we have to find the given, the required, the equation, the solution, and the answer. As you can see in the problem, it was given that the gravitational force is equal to 25 Newton. So I will write down this given to this part. Okay. And another given in the problem, we have 36 centimeter. That is the distance between these two spherical objects. So that is 36 centimeter. I already converted this into meter since the unit needed to solve this problem is in meter. So 36 centimeter will be equal to 0.36 meter. Okay. From the problem, it was not given, but we need the value of the universal gravitational constant, and that is equal to 6.673 times 10 raised to negative 11 Newton meter square per kilogram square. So that is the value of universal gravitational constant. And the problem asks you to find the masses of this object. Since it was given, and I already told you that their masses are equal, so instead of writing two masses as you're required, so I just put 1m because they have equal masses. For the equation, we will have the equation of the gravitational law. That is F grab or force of gravity is equal to G multiplied by the two masses over square of the separation of distance. As you can see, this is not the formula that we need because the missing here is the mass. So we need to convert this formula that the formula will help us to find the value of mass. So let's do conversion. So let us derive the formula. Now, let us derive the formula to get the value of the mass from the formula. So, let us write down the original formula. From the original formula, it was given in the problem that we need to find the value of one mass. Why we need to find the value of one mass? Because, according to the problem, their masses are equal. So, instead of writing two mass, I will change it into this one. So, how it is done? I just multiplied m sub 1 to m sub 2, and that is m squared. Okay, so in deriving the formula, you just have to cross multiply this formula to make it straight line. So F gravitational force multiplied to the square of the distance, no? The formula will be look like this. F grab r squared is equal to gm squared. And then it is not yet done. We need to cross out the unit or the value that is with the missing one. So, as you can see, yung m squared natin dito, dapat mag-isa lang siya dyan. So, anong gagawin natin para ma-cancel yung g? Okay. So, ang gagawin natin dyan, we both side, or divide both side by g. So, magiging ganito na siya. Maka-cancel na yung g sa side na to, and then ganito na yung magiging formula. And then, from that, no, f grab r squared, kailangan i-square root natin yan kasi meron tayong square dito. So, we need to square root both side. So, square root of this one and square root of this one. So, makakancel na natin yung square dito and dito din. And doing the math, the formula will be look like this. So, yung r dito, ilalabas natin siya kasi na siya done na yun eh. So, labas natin dito yung r, and we have f grab is equal to m. Makakancel na natin yung square dito. Okay. And then, the formula will be m is equal to r square root of the force of gravitation over g. So, we already have our formula. Let's go back to our problem. So, I will put here the formula that we've done or that we've solved. Okay, that is m is equal to r square root of the F or gravitational force over g, which is the universal universal gravitational constant rather. Sorry for that. Okay, so let us put this given to the equation that we had derived a while ago. So the solution will be m is equal to r, that is 0.36 meter, square root of the force, which is 25 Newton, over the value of our g, which is 6.673 times 10 raised to negative 11 Newton meter squared per kilogram squared. So, doing the math, pwede na natin itong ilagay sa calculator together, no, para mas sure ang sagot. Lalagyan lang ng parenthesis para maging tama. Okay. So, doing the math, the answer will be, okay, cancel lang natin yung mga units, no? So, we have Newton, cancel, meter, cancel, kilogram, square, cancel. So, meron pang 1 kilogram na natira. And, okay lang yon since ang hinahanap natin is mass. So, the answer will be 220,349.43 kilograms. So, as you can see in the problem, kailangan natin i-scientific notation na lang natin para mas ma-shorten natin. So, our final answer would be 2.2 times 10 raised to 5 kilogram per second. So, bakit po naging 2.2? Pinalo lang natin yung significant. So, yung 36, meron siyang dalawang significant figures. Dito, dalawa din. So, yung answer ko, it must be in two significant figures. So, ganito lang yan. 1, 2, 3, 4, 5. So, that is 2.2 times 10 raised to 5 kilograms. So that is the answer. I hope you have the same answer with me. Okay. So if you get this one, so kudos to you if you got the right answer. So that is the end of our problem. So if you have question, just message me in my Facebook account or in our Google Classroom or in our Septo LMS for questions. And then thank you everyone for the evaluation. It can be found on your Google Classroom. Maybe I will put it on the Septo LMS, but I will assure you that you can find the learning activities for this video presentation in the Google Classroom. I hope you enjoy our class. Thank you everyone.